Hello, my name is Diana Vianescu and I'm a lecturer in mechanical engineering at Kingston University. And today I'm gonna record a video for two-bar mechanism. So basically, you can see it, download it on my desktop. What we are gonna have inside is the tutorial. With the tutorial, I'm gonna go on and off because I don't have a printed copy, so I have to um, look on it on what's going on. Yeah. Let me just explain you first what we are gonna do in this tutorial. So basically, we're gonna do the motion simulation of tooling in Siemens NX. And which is the problem statement? So basically, we have these two links. You can see here, we fix the first link in this part, and the other link will slide on this direction. So the distance between this part and this one should be 500 between O and B, and B should slide on this direction. The distance is 500 as well. So basically we have just two links. Even if you will see we have more parts to upload, so it doesn't really matter. It matters how many links we have. So step 2 is to model the part. I'm not gonna model the part because we already have the parts and they are in Canvas. I showed you in the first tutorial how you can download them. But if you want to do them by yourself, you have them here. So this will be the base. So this one will be link OA. So you can see all the dimensions, yeah. This one will be link OB. And this one will be the actuator. And the assembly. Basically what I'm gonna start with the assembly today. We're gonna do the assembly. So we add the base, link OA, link OB, and the last part. So we're gonna have this assembly, and we want to have the distance between this and this one of 500. So basically I'm just gonna add the constraint, yeah, of 500. And after we're gonna start the motion simulation. So we're just gonna simulate the motion. We will create the links and joint automatically. We will add 2 points. So one on 500 and one on 500 And after we create these 2 points, we want to create a slider. So basically a slide joint. And will be from here to here. So it will be the direction of sliding. Yeah. After we want to just set up a driver, the velocity of 10, and solve it. In the solution, we'll have a time of 50 and step of 100. And after we can animate it and get the graphs. With the graphs, this change a bit, you will see. So you can access the graphs in different way. So more or less, this is everything we're gonna do in this video. So I'm just gonna minimize this one. Like I said, I'm gonna go on and off on it. And I'm gonna access Siemens NX, so you can access it from here, apps anywhere. I'm just gonna type Siemens lunch. You have to wait a couple of minutes until this is launched, but usually, at least on my computer, it works quite well. So it depends a lot from the internet connection. If you don't have a good internet connection, you can just download it on your personal laptop and install it. Okay. I'm just gonna close these files now. I don't need them. Yeah. Okay, so we have Siemens NX. We want to open a new, and you have to be here in the model and assembly. So we already have the parts. Like I told you, if you want to construct your parts by yourself, you can construct in two ways. You can either construct each part differently and after add them together, either construct first part in the assembly, second part in the assembly, and so on until you finish the assembly. So open, and I'm gonna go on desktop to bar mechanism, and first one, I think it was the base. Yeah. And should be absolute origin. Okay. So I'm gonna leave it on this one, on this. So the coordinate system will be in the back. After I will go to assemblies. Be very careful. If you cannot see the assemblies, you can go to files and tick this one. You see, if I untick it, you cannot see the assemblies. So files and tick assemblies. So go to assemblies, add the new component, add, and link OA. I will just press OK. This one I want to be just snap. I will just snap it by constraints. So I'll just put it anywhere I want, and I will add constraint. For this one, I will add concentric constraint. Be very careful. The constraints are quite important. You know, when the software automatically creates the links and the joints, it's considering the constraint. Actually, the joints, the link will be created anyway. So I'm just gonna add it here. Yeah. So this is our second part, sorry. Apply. After we want to add OB, the same by constraint, concentric, and I will have this one here and this one here. In NX, when you're adding a concentric constraint, it will also be like touch align. So basically, it doesn't allow displacement anymore. I will show you after we finish this model. So I will just add the last actuator. Okay. Select it, and I'm just gonna add it here. And the same by constraint. I'm gonna add this one and this one here. And okay, so basically in this moment we have all the parts in our assembly. I'm just gonna leave it like this so we can see very good our parts. So we have all the parts in our assembly. So if we go here and say this one was fixed, and I want to see how this one can move, I go to right click and show degrees of freedom. And you can see it allows only rotation. So that's why I'm saying usually concentric should allow displacement. So shouldn't just if I added concentric here in the back. In SolidWorks, it considered like being touch line as well, so it doesn't allow displacement on this line, on Y direction, yeah. So it fixed it on Y direction. I'm just gonna refresh this one. So okay, and now I want to add this constraint, so 0,500. So I'm gonna add from here 0,500, yeah. I'm gonna go to assembly constraints and distance. I'm gonna choose distance. And I'm gonna go and get this middle line from here. Yeah, just be very careful. It's a bit hard to get it. Yeah, the middle line from here. And then my mouse is just going in all directions. The middle line from here. Yeah. And this distance should be 500. Okay. And what I'm gonna also add, because I don't like how this is staying in here, I'm gonna add the constraints, assembly constraint. And I'm gonna just add parallel. I'm just gonna add a constraint and after I will delete it. Yeah. I'm gonna add parallel between this one and this one. Okay. Sorry, back, because I don't know what I've done. Assembly constraints, parallel between this one and this one. Okay. And after what I'm gonna do, I'm gonna delete it because we don't need these constraints, but I want it to move it in the right direction. Yeah. So I'm just go and but not yet. I'm gonna delete this one. Yeah. I want, so this line, if you go in the tutorial, should be saying it should be moved on this direction. So it should be approximately on this direction. So what I'm gonna do, I'm gonna go and move. And I'm gonna choose this one, specify orientation, and I'm gonna move it. So I want X to be on this line. Okay. Okay. Or approximately, at least. I can double check, like, okay, let me see the, okay, it seems to be quite good. Yeah, you want to have this on X direction. Now be very careful. So we just need these constraints: fixed, concentric, concentric, concentric. I'm gonna delete the parallel one. So I just added the parallel one because I want the actuator to be in line with the link OB. Yeah. And now my model is like this. When you have the model like this and you have all these constraints, and here you can see the constraints here as well. So in Assembly Navigator, constraints and the part, I'm just gonna go File, Save, Save As, and I'm gonna save the assembly with the name of two-bar assembly. Be very careful in NX file names, you cannot have space, so I'm just adding underline. Okay. Now we have all the assemblies, so we can start the motion simulation. So we start the motion simulation. We go through all this. It will automatically create the links and the joints. Be very careful. If you keep the constraint, I put the parallel one, you won't get the right links and joints automatically. So delete it. You don't need. You just need the fixed one and the three concentric and the other concentric ones. Yeah. After we're gonna add the points. So I'm gonna start. So file, motion. You can get the motion either from here. You can get it either from application, motion. So it's the same motion. For me, it's easier to get it from files, but it's up to you. New simulation, okay. Dynamic, okay. And here it asks if you want to create the joints and the links automatically. If you press cancel, it won't create any, so you can create them by hand. I'm just gonna create OK. So I'm just gonna press OK. If I press OK, you have all the links here. You can see them. So we're already created, automatically created, and the joints. The joints, it's easier to see them if you go to static wireframe. So this will be joint 1, joint 2, joint 3, and joint 4. Joint 4 is the fixed one, yeah. You can see inside what's going on. This is the fixed one. The other one are rotation or revolute ones, yeah. So now we want to, so if you have like this, you can go shade it with edges, or you can go and static wireframe. So you can go between them to see what you have inside, yeah. I'm gonna create the 2 points. Just gonna go to menu, insert, down to point, and first should be of 500. If I'm gonna fit in page, you can see it was 500. 0, apply, and you can see our 2 points, yeah. So one it's somewhere here and one it's somewhere here. So they are our 2 points. So what we want now is to create the slider. So the sliding joint. So I'm gonna go and create a new joint. It will be joint number 5. It will be slider. Specify the link. I'm just gonna choose the actuator. And specify vector. On the vector, we can choose the vector from 2 points. I'm just gonna go and choose 1 point here and 1 point here. So they are the points we created. And okay. So, and after I'm gonna go and change the view option. And I'm gonna go and solve it. So basically, sorry, we need to add the velocity. If we don't add the velocity, it won't do anything. So basically, we have to add the driving. Velocity of 10. So here in driver, okay. And after that, we just solve it. Solution and solution. If we click here solve with OK, we'll solve it. Yeah. If we don't click, it will just create the solution, and after we have to click solve. So I'm just clicking here solve with OK, and we have to put the dimension here so 50 seconds and 100 steps. 50 seconds and 100 steps. And gravity is the same, solve it with OK. Okay, it's 100%. We can just close it. And we can animate it. So we go to animation, double click on default animation, and you can see what's happening. So it's going on to this direction. If I want, for example, if you want to return to the finish model, you can finish or return to the model, yeah. If I want, for example, to change the solution, just saying to 70 seconds. Okay, you need to solve it, otherwise it won't do anything. And you can see what's happening. So animation. So it's going from the first point we created until the second point we created. So on this vector, on this direction. Again, you can play it from here. You can stop it. You can play it again. You can export movie, so on. So more or less this is everything we wanted to achieve in this video. So just to make this two-bar mechanism moving in the direction A to B. So I'm gonna return to the model. If you want to plot your results, you just need to go and XY results. I'm just gonna do it a bit smaller. And go and choose what joint you want to. Saying I have joint. Which one is this one? Let me just go starting. So this is joint 2. So saying I want to see joint 2, displacement, X, right click, plot. And you can create new window. So you can see how it works. Or you can go on joint 3. Let me see which is the joint 3. The same here, static with wireframe, joint 3. Okay. Okay. Joint 3 saying displacement on X, plot. You can see just a straight line. Yeah, just a straight line. And you can the same saying the same one. You can create graph object. If you create the graph object, it's just added here. Saying I want this 3 as well. The acceleration or velocity. Yeah, the velocity is just straight. Acceleration, I think, will be good to see it. Acceleration Yeah. So basically you can just go and add everything in create graph object, everything you want. And when you plot, you can plot it like this, or you can plot it on the spreadsheet. I won't try on the spreadsheet because in Canvas now the Microsoft Excel or Microsoft Office, so Excel doesn't work. So I'm not gonna try to do this one because probably I'll get an error. You can store it, you can get the information, yeah, so on all the points, and you can plot one saying, and after you can overlay the second one. It's saying that it's in okay, so I'm just trying to do J3 and displacement on Y plot. Okay, so I'm just gonna go and choose, sorry, J3 displacement on Y, create graph object. So I'm just gonna go and plot this one and overlay this one. So basically it's overlaid, but you cannot see it because it's here. Let me just go and displacement on Z, create graph object and overlay it. Yeah, you can see what happened on Z. So basically you can just overlay multiple results in the same window, yeah. And more or less this is everything you need to know to be able to analyze your motion, so the motion in NX. So you can just simulate the motion, yeah, and you can get the results here on. You can have the results here and just plot them. I'm just gonna finish. Return to the model. Don't forget to save your model file. Save and save all. Or you can save as, but save all, with save all you will make sure you save all the files, yeah. And when you close it, I'm just gonna close the tutorial as well, and you go back, you can see we have the 4 files and the assembly, and we created the motion file, and this is the solution 1. So I'm just gonna double click on motion, and you can, so when you open it you need to double click on the motion, yeah, to open the motion part. So I'm just gonna go and animate default, and you can see the animation. In this moment I'm gonna just turn it off again. If you don't have this file, if you delete these files, you need to just solve it again. So this is, there are the results from the solving. If you create a new solution, we'll create other files with solution 2. Okay, so more or less this is everything you need to know for the 2-bar mechanism. Thank you very much for your time, and bye for now.